All right, so what we've got here is a John Deere 480B forklift. And you see these in mill applications carrying bundles of lumber. They're kind of a reverse looking tractor with a mast on the front. And they're usually two-wheel drive. Some are four-wheel drive. In a mill like over in Beckley, they have a mill, and it's got tractor trailer running gear around it. It'll have dual tractor trailer drive axle tires here on this end and a steer axle single on the back, and it'll have a fork mast and a cab and stuff on it. This one's a little more all-terrain. These big tires go a lot better if it's muddy than the tractor trailer tires do. So of course you don't handle more weight. But anyway, this is a just want to kind of bring you along with this little repair real quick. The machine quit running, and the reason it quit running is because there's a liar on board. That thing right there, I don't know if you can see it. Yeah, fuel gauge right there. It doesn't know how to tell the truth. So it was reading more fuel than it had, and it ran out of fuel completely. So turn it on here and you can see it is showing a half a tank of fuel, and it had zero fuel in it. It ran out completely. So anyway, so we're going to throw some fuel in the tank, and I'll walk you through bleeding the system. So the components of the fuel system, we'll kind of start here. So we've got our tank where we fill it up. This whole unit here's the fuel tank. I took the hood off. I'll show you some time lapse of that coming apart. And so it goes, here's the fuel sending unit right here. This is what's supposed to be telling us the truth, but doesn't always. As we noticed here, this is our fuel line. It feeds right out of the bottom of the fuel tank down here. I don't think you can see it where it comes out actually, but it follows along, goes right under our radiator, and goes right on back through here, goes up right across here and into our fuel pump. Now this fuel pump has a manual pump section in it right here. See if I can get my finger to it. Right about there you can see that little lever. So we'll pump that thing. I'll stick my finger around the backside maybe. Yeah, here, there we go. All right, so we will pump this thing, and it will draw fuel from the tank up through. It's a little diaphragm pump, has a big rubber flap in it, a couple springs and check valves built in here, and it will pump the fuel up into our fuel filter housing right here. Bring it around to this side. Now in the bottom of this fuel filter housing is a water separator. Nearly every diesel will have some sort of water separating feature. This is where this one's located. There's a glass sediment bowl right here on the bottom. Sorry, right here on the bottom. Then there's a fuel filter element. Then we have a bleeder. Then this will be our supply line that will run over, and we'll walk around here to the other side real quick. I'll show you where it goes. I've got some tools scattered here. We were making sure I had put a fresh battery in it and everything. Here is the other side where the line comes out and feeds the top of this fuel pump housing. Now this is a Rusa Master pump. It's an old mechanical pump. On top we have our electric fuel shutoff. This goes to ground. This gets a 12-volt signal from the key switch on, and when it's energized, it opens, and it'll open up and allow fuel to be utilized by the pump. Anything that's extra in this pump comes out this housing. This little guy right here, I want to pause for a minute and talk about him. That is a check valve, and if you ever run into one of these old rotary mechanical pumps, I had a 6.9 Ford and a 7.3 Ford in the day, and they would get to where they would they'd start great, and then they get to where they would not start so great, and you let it set overnight, you'd have to crank and crank and crank and crank till you about turn blue, and then it would hit, or you'd run the batteries dead if it was cold and have to drift start it down the hill, and it was horrible. And I sent a pump out to have it rebuilt, and it came back with a brand new check valve in. The pump ran great, truck started wonderfully. Later did I find out this $12 check valve right here has a little glass-like ball with a spring in it that pushes down, and when pump pressure raises and will overcome that spring and allow all of the return fuel to flow out of here and go back to the tank, and it ends up going back right. You can kind of see it right up here on the top. Well, we'll just trace it down for you. So it goes, leaves the pump here, goes back picks up the top right here and goes across all of the return parts on our fuel nozzles. A lot of people will call these fuel injectors incorrectly. I say ignorantly in a gentle way. They just don't know any better. It's okay, but they're a nozzle. They're not injectors. They don't have mechanical moving parts that increase anything or pump anything. That's all created down here, and the timing and everything is controlled here. On a fuel injector, on a big diesel, it's all done inside of what we'd call a unit injector. So you can see this guy is just a nozzle. It's pumped out here, and it just has a tube that runs up, and there's a tip on it that lets it spray out. Now, that's not to say there aren't moving parts in here. There's a spring, and there's ways to make sure that basically the nozzle has two functions, and its job is to make sure that there is an atomization of the fuel, so it has adequate spray pattern. If it breaks open and releases fuel at too low of a pressure, just fuel drops fall out. They don't burn well, so you have an engine that smokes a lot of white. Incomplete combustion diesel fuel is white, so you'll see a lot of whitish looking stuff, grayish mess, and easily confused with a head gasket, but you'll smell it and you'll know real quick that it's fuel. So again, we're just kind of extending this pump action that happened down here. The fuel was pressurized down here, and it is pushed into this nozzle, and the nozzle gives it the correct spray pattern and makes it all happen at the right PSI. So this pump will say the pressure is 2,000 PSI, for instance. I haven't looked the spec up on this. We'll say it's 2,000, and at 2,000 PSI, you can put this in a test fixture, and we may do one of these, but anyway, we'll put this nozzle in the test fixture, and it has a glass ball or jug that you put the end of the nozzle down in, and you'll pump it up until you read the gauge, and it'll say 2,000, and if it still hasn't started letting fuel come out of it, then hey, it's good. You'll just keep cranking it, and then you'll see it, hey, at 2,100 you'll see it start to crack open, and then you'll keep pulling on it, and you'll watch that spray. And if it's many nozzles are determined, like on a Cummins, you see it a lot, like a 6x12 or whatever, and that determines how many ports and the diameter of each port. So again, this may be a 5 by something or a 6 by something, or usually not less than 5, but you may have a 5 or a 6 or a 7, maybe even 8 holes in it, and then the X, and then that'll tell you what the diameters of those holes are. So that's a little bit of background on a nozzle. Now, while we're here looking at these lines, you can see this one's got a lot of caked up residue on it that is indicative of something going on, and a little rust in there. But the main thing I want you to kind of notice here, well, let's keep talking about this nozzle, these lines, for a minute while we're on this subject. So these nozzles or lines, every one of them is exactly the same length. You'll notice here that they go and they'll make all kinds of weird little loop-de-loops in them because we've got to make sure they're all the same length. If you have especially more noticeable on a 6-cylinder engine, sometimes they'll put a curlicue in it just to make sure, or they'll run it down and back just to take up space, but they all have to be identical in length. And this line is very thick and has a very small hole in it, and I have a tool to adjust timing with on these. It's a pulse adapter for a timing light, and it will still sense that pulse when it comes out, because there's 2,000 psi flexing inside that, and you don't see a lot of, it's not observable to naked eye, of course, you can't feel it, but that very precise tool can feel it. But it's very thick to minimize that flex, because we want that pressure to end up going to the to that injector. Injector, I call it the wrong thing too, the nozzle. So we have our injection line feeding our nozzle, injection line feeding the nozzle. And then we tee off over here on the side, and these are called pencil type injectors, and a lot of times they can be very difficult to remove. So they make special tools to grab a hold of these guys and help pop them out of there, because the seals will swell up or different things will happen, and they can be pretty much a pain sometimes. But we do have some special tools to remove pencil type injectors. They're retained by a bolt over here on the side. Pencil type nozzles, I keep calling it the wrong thing, sorry. Another thing we'll notice is the like on a 7.3 or Navistar motor, a lot of them will screw in, or some will have 2 bolts that hold them down. There's lots of different things there. But you'll notice the return line comes out, and it follows right through, comes up here, and just drops right in the top of the tank. And so it'll drop right down in there, and it'll help cool the fuel while it's in the system as well. So it's a pretty slick little outfit, and pretty simple, very easy to work on, easy to adjust, small pieces, kind of friendly to work on compared to the newer stuff with big computers and things. But anyway, this is an older system. Still see lots of these out in the field, so we haven't seen the end of them yet, and they're very good for folks that don't want to invest thousands and thousands in computer diagnostic equipment and things like that. These old things tend to just work. Now again, we wouldn't be working on this at all if it hadn't been for the silly thing running out of fuel because of a gauge not working. But still operator error. We'll blame operator for that. But anyway, I want to show you a little bit about what we need to do to vent or bleed this system. It goes under 2 names. We're venting the air out of the fuel system, or it's also called bleeding. You'll hear it worded both ways. So, but anyway, right here we kind of see our firing order. I just picked up on that, son. It's 1342 is the firing order on this machine. And but while we're here, I want you to kind of look at that exhaust manifold. And I kind of alluded to it earlier, but do you see anything wrong there? We see this nice rusty brown mess on cylinders. Well, number 1's here, so 1, 2, and 3 they've burnt the paint off of that thing. Now, when we slide back there at 3, we're not seeing quite as much paint burned off, but when we get to 4, there is absolutely no paint burned off of that cylinder's worth of manifold. So that is kind of a red flag. Hey, we might have an issue to deal with here. We look up through there, everything's burned off, and nothing burned off of cylinder 4. Couple things we can do, and I'll show you how to do a cylinder elimination test here, where we'll when we get the thing running, and we'll listen for it to see if that cylinder's contributed to anything. So first things first, let's get the machine running. So we have a fully charged battery in here, good terminals. We put new battery cables and terminals on this thing about a year ago, put a new battery in it, and so now we're ready to mosey around here to the other side, and we'll get started. We'll look at the counterweight on that thing. Wouldn't want that to fall on your toe. But anyway, air filter hides right in here, and these little panels pop off so you can access that. And I think you may have seen us pull the hood off. So anyway, okay, I made it back with a set of pliers here to grab that. We notice it has vertical lines going up and down on these nuts, so that lets us use pliers. I like to get in a habit of never using pliers on something like this that has flats. That's for a wrench. These guys here are made for a plier type tool. This is a groove joint plier. We call them channel locks, but you see the little channels. There's all these different grooves that can go in and adjust your different sizes. Again, there's another good reason why we're not going to do a service out here in the middle of the gravel parking lot is well, again, a couple things. If we spill anything, it's a mess to clean it up, and we want to be thoughtful of the environment and things. And here we are wandering around. I don't know if you can see down in that boot. I've already dropped off down on the ground, and a whole big pile of gravel went in the side of my boot. So that's always fun. Now that brings up a point. There's different. There are folks that do infield service, and I've done it before. I worked out of a truck several years. Different locations, and if you have a nice service truck and all your tools in it, that's a great thing, and a lot of people love doing it. I enjoyed it. There's benefits to that. You can have a dead machine and have everything you need right there. Then there's also the other side, working in a shop environment. If you're working in a shop environment, it's a little more climate controlled, not always. Sometimes it's cold out on a strip job with working out of a service truck. But again, there comes with trade-offs. It's a fun, exciting thing to do. You're out in God's nature out there doing some fun things and getting to see a lot of neat things too. So whichever is good for you. But again, today we're going to do this out here in the parking lot and get it running. We could have pulled the machine on inside, but I don't have any help here right now to do that with, so we're just going to work on it where it's at, and I'll bring you right along with it. So what we're doing, we're just want to see what we have here. That looks like clean fuel. I don't really want to separate out of there. We got water in there, so I'm going to try. I'm going to go grab a different tool for this. I'll be right back. Okay, I also grabbed a drain pan while I was in there. I needed another pair of pliers to kind of hold on to this thing, so I've got a small set. And we call these channel locks. Again, it's trademark name. Of course, these are snap-on groove joint pliers. These are channel lock groove joint pliers, but much like a crescent wrench or a Kleenex or a Band-Aid, a lot of times tools get called by their trademark name, and we can end up with calling them the wrong thing sometimes. So better help turn that the correct direction though. But what I'm going to try to do is turn this nut. There it goes. It just broke free. So I'm turning this little plug on the bottom, and there's a retaining ring right there. I'm hoping. Nope, it's still stuck. Stuck a little too much. We'll get him though. Probably hard to see where you're at there. I'll bring it out and show it to you here in a moment. We'll get this off of here. Yeah, it's coming real slowly. The big ring kind of holds this glass bowl up, and it, if memory serves right, it's kind of formed into a stud. But we'll look here in a moment, make sure. It's been a while since I worked on one of these older machines. The newer ones have a well, I don't want to say it sound too near. You can see the water dripping out of that now. If you can kind of see it, see the water there. That's always an enemy of hydraulic or diesel fuel systems. But back to fuel filter design, this is a kind of early design. Then they went to a square glass piece in the 80s. Late 80s had those. See, we still have water, water, water. Still having water. We're catching in a drain pan. Catching a lot of water. Okay, now we've transitioned to fuel. Kind of see that in there now. Still some water in there though. Let's go ahead and pop this guy off of here. We may have some dirt or something in there too. And that was just what little bit was in the fuel filter that the pump didn't draw through when it ran out of fuel. So we're just going to go ahead and take this on off. Now I'm being mindful of the battery connections there over here. I definitely don't want to bump that hot post over there with any of this metal stuff. Yeah, that was, this outer ring hooked to a shaft that runs up through there. And there we have it. This thing is in desperate need of a service. So we'll be working on that soon, but not today. We want to get it running and get it inside. So we're going to clean this glass bowl up real quick. I'll use some brake clean and spray it out real good. When we get a new filter, it'll come with a new square cut O-ring right here, so we'll change it out. And they usually come, yeah, with a little O-ring right here as well. And that'll keep anything there from leaking. So I'm going to go grab a can of brake clean, some rags, and I'll be right back. Okay, I got us some brake clean. We'll clean that bowl out. I always use brake cleaner, and a lot of guys will use starting fluid. It can be very dangerous. I've probably mentioned that in other videos, but it can be extremely dangerous to use starting fluid around this stuff. Brake fluid is not as flammable. I'll get it right in a minute. It's not just combustible, it's flammable. But the brake and parts cleaner is not. It evaporates immediately. It can still, this kind is a little more flammable than others, but it's nothing like starting fluid. Starting fluid can really get you in a bad shape, so don't use that. So anyway, I was just wiping the goo off my hands. We're old school in it here because we don't have any of the nitrile gloves. Latex gloves like doctors use are they will keep stuff off your hands for a very short while. They'll disintegrate really quickly in petroleum products, and so therefore they don't do real good on this kind of stuff. And here we are in the middle of this COVID mess, and so we don't you can't get a pair of gloves to save your life right now. So we're just going old school here and barehanding it, and I just got done running some hand cleaner on them so I didn't get the camera all filthy, turning it on and off. And I hate getting diesel fuel on my hands. It's it's going to happen. But man, it stinks and just about has to wear off it. And the only other thing I hate worse is gear oil that's been hot in a brake wheel end unit or something. Man, that stuff, it just has to wear off. Kind of like pigment over, same thing. It just has to wear off of you. It takes forever to get the smell off. But anyway, so here we go. We've got it's got a lot of stain in it. You can kind of see that. You could probably scratch on it a little bit and get some of it off. That's coming, but it really is really quite stained up. So there's that piece. Again, this is a square cut O-ring. You can kind of see the square direction on it here. It's not a round O-ring, and I'm going to be kind of gentle with it here. If I pull too hard, I'm afraid I'll break it in half, or not necessarily in half, but break it into one long piece instead of one round circle piece. So that's good enough. We just got the grid off of it, so it'll seal up. And going to take my rag and wipe the bottom of this filter. Now, I'm being kind of gentle with that filter because I don't want to break it loose at the top, because it has O-ring on the top, and then just one more thing to have to clean. Again, we're not servicing it right now. If we were servicing it, we would definitely be taking that off. Now, you can see this thing swelled up. If I put it in it all the way around, you can see there what a problem we've got. So it's going to take a little bit of finesse, but we're going to try to ease it down in there and get it to stay long enough to get it started up on there. There we go. Okay, you can kind of see how it all went down in there that time. So that looks ready to reinstall. I'm going to we're going to bolt here real quick. Just to blow through these little ports here. You can see the crud coming out of it down there, pretty nasty. I'm going to do it the same way the other direction. See if we can get anything to go through it there. Not wanting to, there must be some real junk stuck in there. I believe, yeah, here we go. We'll take this little straw. You can kind of see the straw here on the end of the can. Don't point that at your face when you do this, because that stuff is not friendly to eyeballs. So start that down in there. A lot of junk in there, isn't there? Kind of see all that stuff that just rolled out the finger there. Again, we'll give it a really good clean when we serve it. You can see that O-ring's all smashed out and ugly. We'll change that O-ring too whenever we service it. Again, we're just trying to get it to run today. Don't like to put dirty things back in when I can avoid it. So I'm going to go ahead and tighten this back up. You can see how it's just that fuel will run out of this right here. I imagine there's a baffle in that. That's what it is. There's a baffle right there. That's why we're not seeing it come out. So anyway, so this is where that water junk is, and it is what allows it to go in and come out in the middle of this thing. So that's kind of the theory of operation. The water sets in here, goes in the hole. Just make sure you can see that. Yeah, the water sets down low. You can kind of see where that water is setting in there, and it'll go down that hole and out the bottom, out that drain. In this guy here, usually there's a cut in the threads. I don't know if I can show you to you or not. Get that O-ring to loosen up. Yeah, right here we go. See this cut spot in the threads? You loosen it up enough to where that cut spot becomes visible, and then the water will just run out that little cut spot. I want to clean that up just a little better. Yeah, there we go, nice and clean. Okay, so all that looks good, and again, we service it. We'll put a new O-ring there on our water separator drain. So that looks pretty good. And I'm going ahead and put this on right now because it is not the easiest spot to get to when you're up in there. So it doesn't have to, actually, let me think. I'm going to leave this open first. I changed my mind. I'm going to leave this open so I can make sure fuel's getting there while I'm cranking on it. Because if I, there we go, I can see the bottom of that. That's good. So I'm going to be pumping down there on the bottom, down over here, pumping that little guy. And I want to be able to see when I pump fuel all the way up to where it's coming out of the bottom of this thing down here. And then when I know that, then I'll tighten this one up. I'll loosen that one and pump it till fuel fills up the filter and comes out there. Then I'll go over and do the same thing at the pump and get it all the air out of the primary side of this system, the low pressure side of it. Just better put that fella on first. Yep, just tuck him up in there. And then sometimes these things can be a bit of a challenge to, I'm gonna have to put him in a little different way. Let's try this one. There we go, that's the right way. Takes a little bit sometimes. Another thing too, when we'll service this thing, we will put a lubricant on that O-ring. You didn't see me put any lubricant on it. It's not, oh, I just knocked that. I didn't put any lubricant on this O-ring. I usually use grease when servicing a fuel system instead of oil, like you would on top of an oil filter or hydraulic filter. But I use grease on a fuel filter because it's a little more resilient to being wiped off by the diesel. It doesn't wash as bad. Okay, there's that. Find that center, there it is. All right, now I'm just going to get and tighten this puppy up, making sure the whole time that that square O-ring doesn't pop out of that groove. If it pops out, then we're back to square one. Keeping the pressure up on it so it doesn't paddle around and pop off. All right, there we go. Okay, so now we're getting there. And we don't have to tighten the thunder out of that. Remember, it is glass, so we don't have to get silly with it and bust it. All right, that feels real good. Now, take our pliers, just like we did on the bottom bleeder plug. I'm going ahead and release this one right now while everything is apart before there's fuel in there. I cracked it and I'm seeing some dust. There's some dirt, debris, grease, and grime. And I always like to crack them, spray them off, and then open up, because this one, there's an issue, a possible issue of it falling back down inside that filter housing. And we really don't want that dirt back down in the in that fuel filter housing. Okay, so that looks good. So now what we're going to do is slide over here and pump on this thing a little bit. We're already getting some fuel flow for some reason there. Let's see what we got here. Oh yeah, looky there. See how that thing's spraying fuel? Man, we're in business. We're already getting fuel here. So we'll crank this one up. So that stops leaking. I'm gonna have to get in there with a pliers and snug it up a little. Again, we're not getting crazy with it. It's just plastic. Put that back under there where it's dripping. We don't want to make a mess. We want to be good stewards of the earth, not throw a bunch of oil and stuff down in the soil. So, all right. So now we're gonna. Now another thing I didn't mention earlier is this little pump. If you go to pump it, and I talked earlier about making sure it's actually pumping. You see it starting to fill up there. If I was pumping this, and number one, it took zero effort to do anything at all, it was just kind of flopping around, or there was no fuel coming out, then I'd have reason to believe that the eccentric on the camshaft lies in here. These little pieces here are where your push rods go and touch on the camshaft and run the rockers on the top. If we ended up with no pressure on this thing, if it wasn't pumping anything and there's no feel on it, then the eccentric would probably be pushing up on that little arm inside that that's back on the back side of that fuel pump. You can't see it, it's back in the block. And what happens, that eccentric, basically you have two circles. The camshaft spins in one one plane, and then this little eccentric is cast on it crooked, so it goes around. It's perfectly round, but it's not centered on the same axis, so it's going around spinning. And what it does is when it comes, that little lever, when it comes up, it pushes up on it and then comes back down, and then it comes back around and pushes up on it and comes back down, and that's what makes that actuate. So what I'm doing right now is I'm just hand pumping this guy with a little, oh, there we go. You can see the fuel chute out of it. So we have our fuel filter getting close to full. So I'm going to crank it down just a little and do it one more time. Get those air bubbles out. You can kind of see how there's still some bubbles. Now we're getting some pretty clean fuel there. See right coming out the side there? That's pure fuel. Very seldom do we hear or see air bubbles. So I'm going to go ahead and tighten that one up. We are getting really close here. Okay, we are over on the injection side. We have our nozzles here that we talked about earlier, and we're going to need to be breaking these guys loose here for a moment. So I've got a wire brush here. We're going to clean these guys up. We don't want to open up a fuel system with that much dirt and grime and debris all around it. It's just in anything hydraulic, and this is no different, it's a we have a pump and we have a resistance to that flow, which creates pressure. And a lot of people say, oh, I've got a high pressure pump. There's no such thing as a high pressure pump. There's a high flow pump and a low flow pump, and there are high and low flow pumps that are able to withstand pressure, meaning they will withstand the pressure that of the restriction that we place on it. But it doesn't create pressure. The restriction creates pressure. And again, we have a lot of people that misspeak there, and I'm sure they don't do it to be mean, but wanted to clear that up. So what we have a pump, we have lines that carry this fluid. That's what hydraulics are. It's a fluid being used for a purpose here, and our restriction is this end of the nozzle. We spoke earlier about this nozzle not exactly being an injector, even though we call them injectors sometimes. We hear it done that way, and I even slip up sometimes and call them injector. I think you witnessed that earlier. But it's a nozzle, and that is the restriction to the pump. Now, how do we get a high flow pump? Well, we end up displacing more fluid per revolution or per stroke, however the pump is set up, and that gives us more flow. More fluid gets moved with each little section. Have you ever seen a syringe and the doctor gives you a shot with, maybe had a vaccine or a shot of penicillin or something, and they'll put that in there and they'll draw that fluid out of the little vial up through the needle, and they'll fill that syringe up. And the more stroke you put in that, or the more displacement of you have inside there. So we have displaced all that area with a fluid now. So if we draw up 14 cc's of fluid and then we pump it, our hand would be the power source. The little syringe would be the pump, and we displaced that fluid in one stroke, and it went through a line, being the steel tube, and then it met resistance, your body. So that would be how much pressure that it took. And again, it's all plastic. It's a little rubber piece in there, so it doesn't take much of a pump, as in syringe material type, to withstand that pressure. So that would be a variable displacement pump, because we could pull it back to different amounts each time, and it would be a pump that could only withstand a low pressure. It doesn't create pressure, though. We must remember that. A lot of people will get confused by that. Now, one symptom of a failing pump is low pressure, because it's having internal leakage. So of course, the leakage could be anywhere. It could be an external leak. It could be an internal leak in a fixture, like a nozzle or something like that we're not seeing. But if we're having an internal leak we can't see, a pump's a really good place to start looking. But it's not but a pump does not make pressure. It creates flow. So we've already talked about that. Our pump's hanging out down here, and we're up here to our nozzle. And this is a hydraulic system, just like you'd have in a hydraulic cylinder and or a wheel motor or something like that in a machine. So again, back to that statement I was making earlier. Cleanliness is next to godliness in a hydraulic system, and that's what we have right here. Is this fuel system is a hydraulic system. Now, I have a set of angle wrenches that are really good for this, but I don't have them out here right now. I may have to go get them. It kind of lets us have really good angles on getting to these silly fittings. So what I'm doing here, I'm just loosening these up. And what I want to do, don't want to do that. What I want to do is have them ready to go, loosened up. Now, there may be one on an engine sometime you'll come to that you just can't get to. Don't sweat it. A lot of times you can get one to start with only having 3 out of the 4 or 3 out of the 6 bled. And that one will self-bleed over time. But if it's going to be one of those things that's going to cost you an hour to get that line loosened, skip it. And it'll run on 3 cylinders. I've had them run on 2 before. They don't sound real good, but they will run until and then the running engine will bleed out the system or vent the system. So this one here might be tricky. Oh, it's going to go, yeah. So here we go. All right, wonderful. We have gotten all 4 of them to loosen up here. Now, I'm going to go back and pump on that thing a little bit. I am not going to see fluid come out of here. I'm just doing this right now so I'm ready. we're going to pump, and we're going to see fluid start coming. We're not going to see any fluid, but we're knowing fluid is going to be filling up this housing in the pump down here, and then it's going to come up and vent back to the tank. So I could just kind of listen for the tank. So I'm going to pull this cap off, and actually I'm just going to move you over here with the camera so you can listen for it yourself. And we'll listen for fluid to run back down in the tank. Let me see here where I can put you. About right here. Oh, that's gonna be a good spot. Yeah, there we go. Okay, so you should be able to hear it. You're right above the hole on the filler neck. Now we're just gonna pump till we hear fluid come into there. I think I'm hearing it. The return system might have already had a decent amount of fuel in it. Okay, I think we've got it. I think we're good enough to start cranking now. So what we want to do is go over this machine real quick, make sure you don't have anything laying somewhere that will fall on a battery or something silly like that. So we'll look down in there, make sure everything looks good. We'll kind of look, make sure we don't have something laying on a valve cover that'll fall down in a fan and run out and go through the radiator or through a person. This thing back here won't vibrate too badly. I'm going to go ahead and get everything off of our floorboard over here, and that way we don't have any rattly pieces falling down anywhere or us tripping and falling on them. So we're just going to set everything back here where it's a good safe spot. Again, this is the beauty of a shop. You don't have to looking for tables everywhere. I have a bad habit of anything flat is suddenly a table. Now, not a good habit, but it is what it is. So all right, so we're ready to start cranking on this thing. We're going to verify that the machine is in park, which our indicator up here says that down and back is park. So we're in park. I'm going to hop up in the seat and make sure that on these initial cranks that we are safe. So I want to turn our key to on. Look at our lying fuel gauge there. We've got some fuel in it now, and we're going to start cranking it. I'm going to turn you around here so you can watch what happens. No smoke, because there's no fuel being burned. What we're looking for is wet down there. Ooh, did you hear that thing already trying to start? Oh, we have fuel starting to come out of number, looks like 2 and 3 and maybe even 1 up there. Now, I didn't talk about this a second ago, so we're just going to let it sit here a moment. When we're cranking an engine like this, you never want to crank it more than about 15 seconds and let it rest for about a minute. So when we count, we're counting 1, 1,000, 2, 1,000, up to 15, and then we're going to stop. If we do it in longer cycles than that, we'll just heat up our starter, and we'll end up having another thing to fix. And we don't want to do that. So we got enough to do. So we're going to let that thing sit there for just a second. It sounds to me like it's going to start here real soon. Now, there's a chance it'll start with it dripping fuel like that. And so we're going to do one more quick round of cranking, and then we're going to go ahead and tighten those puppies up, because it looks like our fuel is really, really close to being where we need it. Now, this one has bled very quickly. Now, again, when we look at this, it seems like it's been forever, but if you just dive into this thing and elbows are flying, you'll end up with a really a job done pretty quickly. Now, one thing I want to notice, I haven't seen any fuel come out of number 4, so I'm a little concerned with number 4. We may have an issue there. Remember, that's the one that has the paint on the manifold. We're always looking for other problems while we're fixing some problems. So I'm going to go ahead now and crank it again for no more than 15 seconds, see what it does. All right, see, she's trying to run, so we're going to turn it off. and it was really starting to go there. So I'm going to turn it off, hop off the machine here, and this one is looking really good. So I'm going to crank it. All right, so I'm going to tighten this one down, and it is I'm getting a lot of fluid there, so that's a good sign. It's ready to do something. Just going to snug him up. Oh, I see a problem down here. Let me get you around here where you can see this. You see down here, the top of that nozzle there's a nut turning below my nut. See that one right there? So we're gonna have to employ another wrench there so we can hold that steady, because it's just spinning on the shaft, or tube rather, of our pencil type nozzle. So we're gonna slide this little fella in there. I'm not going to use that one. We're going to try a 9/16, see what that says. Oh yeah, there we go. That's more like it. Now this is an old enough machine. This thing was all still US made. So most everything on this puppy is standard wrench size. American or SAE or fractional, depending on who you're talking to and what company. Not metric sized. Sometimes even in these older ones though, if they have a Bosch system being built in Germany, they will get tight. The German ones will still be metric, even on the older stuff. Cummins, a lot of their stuff metric, that in these older ones too. All right, so we're going to hit it one more time here. That was interesting. I turned the key off, but it kept running. So you see I grabbed this wire down here, pulled it off of the injection pump so that it would quit. Several reasons that could have happened. It could have been running on its own fuel. I'm really, it could have been too much pressure in the pump and it had to go somewhere. I really don't like engines that try to run away with me. I've got a rag laying right over there on the floor that we cram in the air box next, or in the air intake next. That would have been step number 2 if she would have kept running after we'd turned the key off. Runaway diesels are zero fun. The Detroits are really bad for that. The old 2-stroke Detroits, they still had a crankcase full of oil. They didn't run like a mix or anything, but they ran on 2-stroke principles, and they're really bad to run. They even had flat valves in them to keep them from running away on you when you're I don't know, that one was loose all the way now that I feel it. So I'm going to go ahead and loosen it up, because I'm very interested to see why this one's not hot right here. There are no signs of heat. So again, we got a rag here. We'd have crammed it. I'll show you about that right now. I'm thinking about it. Right over here, see that hole right there? We would have filled that hole full of rag if it hadn't stopped running. So that would be our next course of action had she not turned off. So we got our wire hooked back up down here on the bottom. You can't see it there, but anyway, we got it turned back on, and we're going to crank it up one more time. All right, we have lost smoke on top. I'll let you look at that real quick. So I'm hearing something drip over here. Let's go over here and look. What do we have dripping? We may have something loose here. Maybe it was imagination. I don't hear it now. All right, so let's slide back over here, see what we've got going on. Maybe we weren't as bled as we thought we were. It could have had some fuel still in these lines and an air bubble pushed it to make it run. Could be. So let's go ahead and crank these back loose. I'll do these right here that are a little easier to get to. I want to just verify that we have fuel coming out of them. I think I heard a rush of air right then. All right, so let's see what we got when we crank it again. There's our 15 seconds. I think that's what happened. I think we had a housing that was still had some fuel in it, and it pumped it up through here. So we're just going to loosen it back up. It's no big deal. We've heard her run once. That's a good thing. Now the newer machines, you don't have to do this. Or if it's one that has an electric fuel pump. I'm typically more of a fan of mechanical things, but I do like an electric fuel pump for that purpose, because it'll just pump it full and you're good to go. And so that's a kind of one of those things. It's I really don't mind an electric fuel pump because it'll help you bleed one down really quick. And then the newer stuff, it builds, it will vent itself out really quickly. Now I'm just taking my voltmeter here real quick because I pulled that wire off to get it to turn off. I'm just going to test voltage on this real quick just to make sure I'm getting some. So I'm just going to test right through this solenoid. Not showing any right. Let's go ahead and see up here. Not showing any. That's good because it's off, and that's what we want. That means it would turn off. And then we're going to do it one more time onto that lug. I'm still not getting any reading there. Oh, I just heard it make noise right then. We may not be in as bad a shape as we think. All right, now we have power. You see that? I think we're bled. I think it was just shut off. Let's try it again here. Hit this thing here. Get it out of the way, turn it off. Always pays to double check little things like that before you get too busy. Let's go ahead and let's just try it here. All right, we're seeing quite a bit of fuel there again, aren't we? That's good. Let that thing start or cool down another minute. We're starting to see some fuel over here, so that's a good sign. That means our pump is probably okay. I'm gonna loosen it up just another little bit. It's pretty loose, and we may have a bad nozzle. We may have to have that thing tested. If it doesn't run, we'll do a cylinder cutout test and see. Let's crank it again. All right, I like what I see there, so we're going to head and run a few of these guys in. We're getting fuel. Oh, yeah. Now you see I'm running this wrench backwards. I'm not feeding it into that jaw. You can see that's backwards. But on a spot like this, sometimes you put a wrench where you can get a wrench. If we were breaking a fitting loose or a bolt rather, fastener of some kind, we would avoid that. I really don't like doing it right here, but we don't have a choice. So sometimes you just put your wrench how you can get it on these things. And again, we've got a set of wrenches in there that are made for this. They're angled. They have open ends on both ends, same size, and they're angled at different angles. So they you really have 4 different options of hooking it onto that thing, and that's really handy. And sometimes you got to get creative on your wrenches, especially in hydraulic systems. You'll find yourself having to cut them off. And we had to cut one not long ago working on a Bobcat, like an 1.25" wrench, and I had to cut the thing off short so it fit back in the hole that it was in. Really hate tearing up tools, but that's what you need for the day. You end up doing what you got to do. So, all right, we're tight now. Let's see if she'll start. And she turns off. That's good. Apparently when we were putting the battery in, we ran that throttle to wide open. You never want to start something wide open. That's a bad idea. Should have checked that. All right, let's see if it'll start again. Also looking for any leaks or bubbles. Looks like we're good. We'll do a cylinder cutout test here. See if this thing changes sound. I definitely heard a change. Listen for it. Here it come back. Here missing. Okay, I think you could hopefully hear the difference in each cylinder as we did a contribution test there, a cylinder cutout test. We wanted to see what each one of them was doing, and if we would have loosened one of those and the engine would have stayed running exactly the same, then we know we had a dead cylinder. And that dead cylinder could be any multitude of things. It could be a bad nozzle, a nozzle's not got the right pattern, dripping, could be a low pressure, could be something in our injection pump, could be a valve adjustment, could be a hole in a piston, could be a bent rocker arm, bent push rod, broken camshaft, could be a multitude of things. So anyway, what we did there was verify that all cylinders are contributing. When we did the cylinder cutout test, every one of them changed the sound of the engine. So that is a very good sign that the engine is at least running on all 4 cylinders, since it's a 4-cylinder. But anyway, I hope that was helpful for you. We're able to see the how the entire system from beginning to end, the fuel flow, and we could see again the fuel starts at the bottom of this tank and ends up right up here at the top, and you kind of see the whole circle of how fuel travels. And again, there's a lot of fuel that doesn't get used, that other pump pumps up here, that just continuously circulates, and that helps keep it cool. So we see that happening as well. So anyway, hope it was interesting for you. Okay, one more thing real quick. We pressure washed this machine a while back, and just to kind of get the heavy, crummy stuff off of it. But since we took the hood off, we've noticed we got you know, some areas that didn't get hit by that pressure washer. So what we'll do is before we take it into the shop is we'll run it through the pressure washer again and get it all cleaned up good, get all this stuff washed off real good, and then it's a whole lot easier to work on a machine that's clean. You end up less chance of hurting yourself. You're not slipping because stuff's dirty and gritty greasy and slippery, and also you just do a better job. You're not getting dirt down inside of stuff. And I think, let's walk over here real quick. I want to notice here the valve cover bolts look like they have never been off of this machine. I don't see chipped paint. Even though this machine has been repainted, you would see paint chips on those bolts, and I don't see any. So let's look at our hours real quick. I can't remember the hours on this machine. It has 1,067 hours. So it's common on these at 1,000 hours to do what they call a 1,000-hour service. And this machine has some age on it. It's probably, wow, it's probably, I'm going to say at least 40 years old. At least late 70s, early 80s, somewhere in that time frame, just by the styling of it and such. Maybe even mid 70s. But it's extremely low hour machine. You can tell when you get on it. I mean, the pedals still have all their dash marks on them, the little checker marks. The steering wheel isn't worn off. You know, there's a seat, can't really go by them because they get changed out pretty evenly, or pretty easily. But the forks are all in good shape here. The forks are not bent. Another thing you look for is the crispness of the ends. I'm not sure if that's showing up in the video, but they aren't all round and wore out and bent and all tips wore off and drug off on them. So I have no reason to believe that the hour meter is not correct on this machine. It hasn't seen a hard life. And also the floorboards are not wore out where you get on them. You can see a little bit of wear right there, but it's not worn down slick right there. So I have no reason to believe that 1,067 wouldn't be accurate. It has been repainted once. You can tell. Right here you can kind of see the different colors of paint right here. Sometimes they'll have different primers on these machines, but right here you can see some mask lines that were used and two different colors of paint right here. So again, just some things to look at when you're looking at a machine to see if an hour meter is correct. So there's some quick little things. Here's some tape lines right here as well, you can see, and overspray down there. So it's been painted once, but it's a really decent, solid old machine. With all that being said, at 1,000 hours, it gets a valve adjustment. So we're going to go ahead and run the valves in it real quick one day for you. All right, while we are putting the battery in here, I'll kind of let you look at that real fast. I think the battery went dead on the camera while I was shooting this, so we lost the end of that. But anyway, just kind of looking at the machine here. This is negative ground only. You see that sticker? You won't see that very often anymore. Excuse me, on newer stuff, because just about everything is. But again, this was in the time era where every now and then you'd run into some positive ground things. Examples of that, a lot of the older tractors, John Deere, and the little farm models that you see on this channel a lot, little 100 Super A's, 100s, 130s, 140s. They were all positive ground, so it was a little bit weird. And so they'd always put that sticker on the stuff in that time frame just to make sure. Here you can see the cables we put on there. We heat shrink, actually filled them with solder and put they're a brass type terminal, then fill them with solder, heat them up, and then put heat shrink on them, and you can see the battery sliding down in there. But anyway, that's a little bit about what's going on. I hope it was enjoyable for you. I just kind of turned into a long video, but there's a lot of information in there. So anyway, hope you found it enjoyable, and we'll go ahead and let you finish checking out, throwing the battery in, and we'll. Another thing too, I didn't mention. I don't know if we see it on here, but after putting the battery on, again, maybe I ought to talk before we shut the video down here real quick. You always want to hook the red terminal up first, and the positive. I always like to make and break connection with negative. You'll end up having less chance of spark, which will end up being less chance of explosion. So you want to make the connection with the black one, meaning you hook the positive up first, then hook up the negative, and then if you're unhooking, you always unhook the negative first, then hook up the positive one. And when we're finished, we like to put Vaseline on the terminals. That keeps that whole area sealed real well and keeps corrosion down. I hate to admit it, but I did learn that from Massey Ferguson. But we had a 240 Massey at school, and in the owner's manual there, it talked about using petroleum jelly to seal the terminals up. And honestly, it does work well.
you can put it on a battery, and after it runs for a day or two, it'll warm it up enough, and that petroleum jelly or Vaseline will just ease right all down in it and give it all a real nice coating and keep the elements off of it. So really neat little trick there. And but anyway, like I say, I'm going to turn you loose there, and we'll see you on the next one.